Go.
Okay.
All right, so we're doing a presentation on fox hunting. Now, this is the idea of looking for a Wi-Fi network, and we're going to be using signal strength for that. And yes, you could come at us for that.
Why do you want to find a Wi-Fi network?
Why would you want to? Assume you have a rogue network, and in dorms you're not allowed to have another network besides RIT. That's to prevent. That's to make sure that the Wi-Fi experience stays pretty good for everyone else.
Change the size of the projector, please. Speak with your chest. Thank
Yeah, any unauthorized networks. So if I'm in an enterprise network like RIT and I don't want someone popping up their just random DHCP client and router that they have in the middle of their dorm, then this would be a great way to find that network to talk to the people in question. All right, I'm Josh. I'm a second year. I like Linux and longboards.
So I'm Michael. I'm a first year. I really don't show up to these. I have calc every single day here, but I'm mostly at Code RIT. So if you guys want to go brick hacks, if you guys want to show up to brick hacks, just ask me about it. I'm also first year. I said Z Shell and Monakai Pro Elitist. So very uptight about my console.
And I am Chris. I'm here. I do things. I don't know what to say. I'm a first year.
Hey, you guys need to speak up. No one can hear you.
Yell at the back. It's not that you need to speak into the mic louder. You need to speak to us louder.
Nobody expects that.
It's hard. Try.
You see, we were looking for a group name, and nobody really expects the Spanish Inquisition, so. All right, so I mentioned a bit about this earlier. So we're going to take the BSS ID, so the MAC address of an access point. We're going to look for it based on the signal strength that we can see through a Wi-Fi interface card in a computer.
So our process went something like this. First, we were like, there's this library, Scapy. You can do stuff with raw sockets and all that. We're going to use that. We're going to pick up the beacon frames and make our own probe requests. That's unnecessarily complicated. So we tried to find a different Python library, Python Wi-Fi. Could do something similar, except slightly easier, if we could actually get it to work, which we didn't. So then, we just found library access points. It gives you access points and their signal strength. That makes it a lot easier. So we just used that.
Besides dropping mics, so our experience with this is entirely OS and driver dependent. We ran into vastly varying results based on both the wireless card you use and the operating system you're running. On my Linux install, the driver seemed to cache, Wi-Fi search results, and every time that you scan for a network, the driver would just cache it, and that led to some very useless information for our purposes. We actually found OS X worked the best here, and Windows works pretty well as well.
So going over the access points library real quick before we actually start getting into it, it's really simple. There's like 3 actual commands you can use. So the first one's get scanner, just opens up an object so you can scan for access points. That's about it. Next method of it, it's the only one you can actually use, is get access points, and this just returns a list of every available access point. This is also kind of laggy if you're on a network with a lot of them, so it's not the best for large-scale things. And then each access point, the only data you have for it is an SSID, BSSID, quality, and then security. So now here's our demo. We're going to hope this works. I'm going to hold this up for me. It's also worth noting that the access points library, you can just use it natively, so you don't act. Oh, okay. Let's just zoom. Oh. Let's look at that. Look at me not using a Mac for weeks. Oh, look at that beautiful console. Okay. Wow. Yeah, I get that. So the library itself, you can just type in access points and see every related access point in your area. So this is what we used, and then we actually end up parsing this. So I'm going to use this access point here. I'm assuming that's the one right there because it has the highest quality of 102. And then once we can lock onto this access point. So for our library, or for so this, we just have a couple commands you can actually put in. You can clear like repeating inputs. So on Windows, when it caches it, you'll have a lot of the reads just being the exact same quality, so it's pretty useless. So we actually hide those. And then, but on OS X, it actually does update pretty fast. So do Python 3 access point, and I'll just plug in this one. Should be the one here. So once we actually put in one, it'll update. It should be about every second, but depending on how many access points there are, it's actually a lot slower. So it could be up to 5 seconds. So I can't move this much closer because of this dongle, but if I move it slightly closer, you'll see it getting hotter up to here. And that's just the gist of how this actually works. So we've actually tested this walking around buildings and labs, and it does in fact work. Like I said, I think the main drawback of this is how OS dependent it is. The only system really worked well on was OS X. On Windows, you get a reply every second, but it doesn't really give you any new information.
So future work is, let's continue getting this to work with Scapy. So right now, Scapy basically works, but the problem we ran into would be transmitting the access beacon. You know, the beacon that looks and says, hey, look, I'm here. I want to find other access points. Once we have that down, transferring this into Scapy should be easier. And this would also help with the problem on Linux, where you don't have as many usable updates as on OS X. And in addition, we could also use the Scapy code to implement with something like a Wi-Fi pineapple detector, which would a Wi-Fi pineapple basically sends out a bunch of response to beacons from a laptop and says, hey, I'm this access point even though I'm not. So as a result, your home AP, you could be connected to your home AP in the middle of an airport when your home AP is 50 miles away. Using something like this with Scapy, we could detect that. All right, and that's our GitHub.